started recording now. If you're watching on YouTube later, I'm doing this contest, and because I already solved ABC like 2 years ago, I got some wrong answers and time limit exceeded for DF. I will now upsolve DF. And warning, those are quite difficult problems. I will most likely do some thinking and then also look up the editorial. Let's start with D. If it was 2 years ago, then I'm quite sure I will not remember anything about problems now. Good set. The distance between any 2 points is not square root of D1 and not square root of D2. The coordinates should be up to 2n. From a grid of size 600 by 600, choose such 300 square points that we don't have 2 points with this distance or this distance. Basically, the x square plus y square shouldn't be D1 or D2. I completely don't remember this problem. That's my memory for you. It's exactly like if I solve this problem for the first time in my life. Let me open Genie. We will need d.cpp. There is a big grid. If I choose this point and D1, let's say, is 5, then it means I cannot be, this corresponds to move by a chess knight, where those two cells become forbidden. In particular, D1 can be 1. Can I solve the problem for those constraints? And now it means that I cannot take 2 neighboring points, and I cannot take point and point bottom right from me. This is then forbidden. But it seems that this is a good choice. And so on. This could be exactly n square cells. Grid size is height equal width equal to n. And I need to choose n square cells. So we barely are able to do it. I wonder what about bigger D1, D2? Maybe we then can do more. But the number of forbidden cells is 8 usually. Can it be bigger? No, it's exactly 8. No. If D1 is something, let's say 25, then I cannot be 5 units away. I cannot be 3 and 4, because 3, 4, 5 is a Pythagorean triple. I messed up. No, I didn't. Those will be forbidden if I take A. Am I right? Cannot be 5 units away. Yeah, it might. 3 and 4. Think like that, and of course the bottom is symmetrical. It would be nice to choose points A having the same forbidden points. On average, I'm fine if a point forbids 4 other points. No, 3 other points. Per every taken point, I can have 3 non-taken points. If I go in some particular direction, maybe I say we go from the left, and this A will forbid 3 new points. And that's only for D1. We will also have D2. I would guess that D2 equal to 1 is quite tricky already. Because then I cannot take neighbors of A. So I can take half of the grid. Should I consider those two separately? Consider this, then we take half the grid, and because there is some D1, we again take half of the grid. If it was problem worth fewer points, then I would maybe try greedily going from top left and taking cell if I can take it. Maybe I should think about circles, because what is forbidden is a circle with center at A. Or we can think about it in some other way. If we forbid X, it's good to take things at distance 5. So I can draw a circle with center at X, and I can try to say I want to take those points exactly on the circle. Some ideas, chat? If you see something reasonable here, something to start with. I wonder what were my submissions for this problem. I got time limit exceeded, and wrong answer. Whoa. So in the past I passed almost everything. I can always, instead of looking at the editorial, look at my own code. I don't know if that would be cheating. Since there are 4 and square dots, grid can be divided into 4 parts. And 1 point from each part can be taken if D1 and D2 are small. Well, I agree if D1, D2 are 1 and 2, then I take every part of the grid of size 2 by 2. But what do I do if they are any bigger? Like 3. Then parts are not independent. Circles. Will I take points surrounding A? Should I also take those? They're quite close to each other, so if D1, D2 are big, it shouldn't be an issue. Yeah, just trying to think why grid is 2n by 2n. It's a reasonable thing. It's a reasonable thought to have. Should I maybe... No, I cannot... Should I take points at distance half of D? Something like that. Just make it more of a circle. Because I don't want the furthest point on the right and on the left to be at wrong distance with each other. Do I have Codeforces account? Yes, I do. Same nickname. Saturday evening for Europe, there will be my lockout match against Steven. Info about it is on Codeforces. Eknerwala will do the commentary. So, by the way, twitch.tv/Eknerwala. Follow him to see our match on Saturday. $2,800 is good in Codeforces. It isn't bad. I'm kind of stuck already. This problem, constructive problems are often about not really moving forward for a long time, just having stupid ideas. Where non-constructive problems often consist of several steps. And you keep moving towards the solution. I have no idea what my solution was back then. Because I am solving, I will just try to work on my idea. Is this while true try to do something? Yeah. While true 1, 2, 3. I tried to hack this problem. And I was quite close, apparently. Are those 3 different algorithms? There is some random shuffle. Okay, just 3 slightly different algorithms, but similar to each other. And in while true loop, I do all of them. Apparently, it was not good enough for only 2 tests. That's still nice. Maybe something like this is a solution. Maybe like you can come up with a randomized algorithm where the expected number of points you will get is size of the grid over 4. So sometimes you will get over that, sometimes below that. Schedule command is something I should create, but that's later. How does it work if we have 2 and 3? I'm stuck for such a long time that maybe it's good to work on some example. Take this, then I cannot take those. It's not that I need to not do anything from this square of size 3 by 3. I need to take something more. Should I take this? Oh, wait. Those two are forbidden and those two are forbidden. And this one. Because this one is at distance 2. Square root of 2. No, I'm stupid. 2 only forbids this cell. If I consider 4, then we were talking about square root of 4, so then those are forbidden, right? Okay. Should I choose this cell or not? It seems bad because it doesn't have any common forbidden cells with my previous A. Solving constructive on stream is scary. Doesn't scare me. This point seems stupid to choose because it will forbid this one, and if I take this, it will have all the different forbidden cells than my previous A. So maybe we don't do it. I will put question marks, but I'm guessing that we shouldn't do it. But then from the next square of size 2 by 2, we also need to take something. Is it true that for any d1, d2, it's possible to take something from square of size 2 by 2? I can check that with brute force. Let's treat it like this. Can I choose? Like, of course, empty lines don't matter. They are just for my convenience. Can I always... When is it true that I can always take this? And so on and so on. And the distances between every A, so every distance taken is square root of some even number square plus another even number square. So this is square root of 2k square plus 2r square. Actually, I'm only interested in distance square because distance square should be different from d1 and d2. This is equal to 4 times k squared plus r squared. It's 4 before goes before brackets. If d1 and d2 are not divisible by 4, d1 modulo 4 is not 0 and d2 modulo 4 is not 0, then just put a in every top left corner. Now, otherwise, in particular, what happens if d1 is 4? Then if I take this a, I cannot take this one. Can I fix it? In particular, if both are divisible by 4, no. Is this true? This first a, it forbids only one of those 4 cells. Well, a over here in this position S would forbid no, with a single D, I think we forbid a single cell. No, because there was that thing with vector 3, 4 and 4, 3. Both have the same distance. So from from this S, 1, 2, 3, 3, 4, I think we forbid those 2 cells. From this cell, if distance d1 is equal 5 squared, 25. If I cannot have the distance of square root of 25, then if I take this cell, I cannot take those 2. But maybe this is only possible on kind of the main diagonal. I don't think that it's possible that, for example, 620 and 719 are the same element of similar Pythagorean triple. It cannot be true that 6 square plus 20 square is equal to the other thing, 7 square, 19 square. Because 20 square is much bigger than 19 square. So this is only possible if it's ABBA. Why do we need uptime when we can see? I don't know, uptime is the default command in Twitch. I didn't make it. But this seems promising. In particular, maybe this is enough to take my old solution, where while true I tried something, and add this if condition, and then it will work. It is a good idea to think along diagonals of rectangle for choosing points, because then they might have common forbidden points. I started from thinking about common forbidden points. Like for this A, I thought that maybe we need to move 2 D units to the right, so somewhere like here. Or that if this is A, then those 2 points are here, so I should take A somewhere here. But it seems so chaotic. This is why I switched to thinking about now taking a single point from every square of size 2 by 2. Or are you saying this because you know the solution and you're saying that we need to think about diagonals of rectangle? Is there something special about D1 being divisible by 4? Does it mean that this A will only forbid top left A's? Of course, there is also D2. What if you brute force 2 by 2 squares for picking one point? I mean, but there is the whole grid. When I'm here, I would need to remember what happened so far. It's not that squares are independent and I can look at each of them. Like each of them separately. If D1 is divisible by 4. Odd number square is equal 1 modulo 4. Even number square is equal 0. If something is divisible by 4, it must be even square plus even square. Of course, can be 2 different evens. Then D1, top left corner of a square will only forbid other top left corners. So if D1 is divisible, are divisible by 4, then I think that each of 4 points, I mean those points I marked, are independent problem from choosing a subset of those points B, and so on. So I can recursively go and solve 4 smaller problems. They are actually the same problem. So just divide n by 2, solve that problem, and copy it. If for smaller n, is n divisible? N isn't necessarily power of 2. Maybe that's some small issue. But it seems reasonable to divide D1 and D2 by 4 and go solve the problem only for those A's. This way, size of the grid will be divided exactly by 2. Seems fine. I was thinking that there are D1 and D2 and the forbidden points lie along the sides of diagonal of rectangle. Oh, that's not true. But D1 and D2, we are not talking about Manhattan distance, Euclidean distance, so it's a circle. If D1, D2 are divisible by 4, modulo 4, you can choose those points. I don't agree with you. If this is the grid, then those 2 points have distance divisible by 4. I mean the square of the distance. Okay, I assume that this is not a big deal, that we can handle the fact that after dividing by 2, size of the grid will not be even. Maybe we will recurse in 2 cases later, that size is even and odd. If size is 17 now, by dividing by 2 we go to 8 or 9. This should be fine. I mean, I will get back to this problem, to this subproblem at the end, but I'm guessing that it's easy to handle. If this is the case, so, well, yeah, D1 is a form 4 times K, and D2 is, well, it must be 4 times K plus 1, because, or not, or 2. Let's think. Even square plus even square gives us this. Odd square plus odd square is 2 modulo 4. Odd square plus even square is 1 modulo 4. Those are 2 possibilities. But, so this is 1 or 2. In both cases, D1 and D2, I wanted to say are independent, but it's not true. Still would be nice to say that kind of every second column is done in the same way. Let's say that it's odd plus odd. Let's consider this case. For example, it can be 2. Then 2 points are safe if their x distance is even and their y distance is odd. So if I say that I will only take from first column, third column, fifth, and so on, this way I guarantee that for every 2 point, delta x is even. Actually, it makes it difficult for this case. Or no. Maybe I should always divide one dimension by 2. I would say this seems like going in the correct direction, at least. This is what my intuition tells me. Not that my intuition is always right. I could check with brute force if it's true that it's always possible to take 1 point from square 2 by 2. I don't really now rely on that. I consider all possibilities. Maybe we will split the grid in half and then replicate this drawing. Like if D1 and D2 are small, no, not true. I wanted to say that solve smaller grid and then replicate it. But still on the boundaries, there might be 2 points close to each other. Checking brute force is a good idea for small n's, but I assume it's correct. It's not that I have other ideas to investigate if this one is wrong. Oh, one more thing I need to do before the next stream is I'm going to add Twitch chat messages below my face, like here. Because if now, when I stream on Twitch only, there isn't much spam. Massive for graphical objects? No. I don't think so. But if you wanted to hear try patterns for small n, no, that's not the way to go. Maybe one of those two cases is easy. In particular, if that's the case, this and that, then 2 points distant at odd is easy to do. I mean, they do not collide for sure. Maybe take like every second column, or every second row will be easy. Solve those separately, but we need to pass information that dimension was divided by 2. But n is not a power of 2. Strange things will keep happening. But if I go recursive, no matter that d1 and d2, if I go recursively to a grid consisting of only every second row, then I'm fine with that, only if it's impossible to choose 2 points, one among ones and among twos, such that they are at wrong distance. But maybe that will happen. Geometry, I thought about circles at the beginning. If two distances is odd, then the third distance must be even. Maybe. We have two cases. D1 must be this, D2 must be one of those. And maybe in one of those two cases, I can know what happens with a triple of points. But what if I investigate distance of AB, distance of BC, and distance of AC? How can they behave? I don't see what it gives me. Like what? So what? If I detect that 3 points cannot be at the same time bad for each other. Even square plus even square. So combination of those two means that it's okay to have odd x distance and odd y distance. But if I take point 0, 0, and then I take point 3, 7, Any other point will be in bad relation to one of them in terms of parity. What if I have those two forbidden? Now I want to take here even odd. Wait. No. I wanted to say that in some case I can choose a solution only among ones. Not bothering with twos. If I'm fine with any even comma odd distance, brute force the solution to see if we find some pattern. There are too many different D1 and D2 possible. But yeah, maybe. If I'm mainly concerned about those two cases. But almost always when I choose some D1 and D2, I think that the number of solutions will be huge. And just one of them maybe would show me a pattern. Assuming that I take exactly 1 point from each square, let's see what happens for grid 6 by 6 already. There are 4, 2, how many there are squares? 9 by 9, 2 by 2 here, 9. So that many ways to choose point from every square. That's fast enough. Of course it will be smaller because some ways are forbidden. But will I see any pattern here? I don't think so. It is only 3 by 3 squares. I have a geography lecture and want to do competitive programming. Well, just if you want to skip something else to do competitive programming, at least train hard for competitive programming. Okay, this takes already a lot of time and I want to also do E and F, so I will look at some prefix of the editorial, not the full thing. Oh, it is a graph problem. Turns out that in this problem you are given two bipartite graphs with V vertices, and you're asked to choose V over 4 vertices that is an independent set of both graphs. You're given two bipartite graphs with V vertices. Okay, why is that bipartite? D1 indeed creates one graph. If I color cells of the chessboard white and black, then odd will only connect no, odd even would only connect black to white. What about this? Odd, odd. Then I can paint first row black, then white, then black, white, and so on. Then also it will be connecting black and white only. And for even, I never... Is it live now again? Here we go. I'm changing my internet provider this month. I don't know, for the past year I had some issues with the internet. We back. I hope... I needed to restart OBS as well, and now the recording will be split in half. Today I'm, instead of double streaming to YouTube as well, I stream to Twitch only and record myself with OBS. Now I will have two files instead of one. Okay. So why is this always bipartite? If I color the grid like this, if one edge is odd at least, no, if both edges are odd, then always one will be connected with two. So bipartite. If it's odd even, then I need to color it like a chessboard. And then again, we are fine. If it's even, then I have 4 independent components. I can divide by 2 and blah, blah. They prove it. In case D is odd, this is easy. Oh, we need to focus on the single D. Yeah, I focused on the single D. If D is odd, okay, standard chessboard coloring. If D is even, I have completely different solution, but I think my proof was similar. And now we have this interpretation. What do I do with that? I need a drawing. There is some relation between points in one graph and the other. We don't know that. Like, I mean, we know the connection. For example, maybe this point has name A, and then here this point has name A. This is B, this is B. C, C, and so on. And I need to choose if total on each side here there is how many vertices? V over 2 or just n? Yeah, each side. On the left here we have n, on the right here we have n. So in total 2n. The other graph also has 2n vertices. I need to choose n over 2 vertices. How do I do that? For D1 and D2, these are the two graphs. Yes, yes. This is a graph for D1. This is the graph for D2. Independent set in their joint set of edges. Yes, but if I connect that, it stops being bipartite. And then it becomes NP-hard problem in just a general graph to find independent set of big size. Either we will do something greedy, or it will be something with augmenting paths. I hope not the latter, because I don't like flows, matchings, stuff like that. If I take this point, I cannot take some of those. I already chose some points, and also they correspond to some 4 points here. This is not a good connection, but I didn't choose B. This. Can I always choose one more point? So can I do some augmenting path? Assuming that we don't yet have that many vertices. And yeah, Atcoder has beautiful problems. Why do we have 2n dots for each bipartite graph? Actually, it should be... Sorry. The total number of dots, so V is equal 4n squared. So on each side I have 2n squared. Let's forget about the n completely, maybe. Every dot represents some cell of the initial graph. So let's just say that we have V vertices, and well, V is equal to 4n squared, but this doesn't matter anymore. And we have V over 2 on the left, V over 2 on the right, same in the other graph, and we want to choose V over 4 is independent size of independent set of size V over 4. Now, can I do things if this is an arbitrary graph? What if this is full? Each of those graphs is full. all the edges are here. Can I still do it? Oh yes, I find, that's so easy now. Find intersection of left and left, left and right. One of those will be good. Done. Okay, the end was very easy. If we have V numbers from 1 to V, split into 2 sets, and here again split into 2 sets, just take one of them. Let's focus on this left part here. And its intersection with this and that, one of those, the bigger of those two intersections will be of size at least V over 4. Like, if you consider V over 100, V equal to 100, then this is of size 50, and now this is of size 50 and this is of size 50. So for example, intersection of our 50 with this is maybe 17, and with this it will be then exactly 33. Well, that was easy, right? Yeah, they say there are 4 intersections of left, 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 right, right, left, right, right. So one of them must be of proper size. Damn it, such a nice problem. Such a nice problem. To implement it, I need to understand. What do I need to understand? I need to understand how exactly to create the graphs. And my proof was different than theirs, so well, if this odd, then we have the same thing. And if this even, I wanted to go recursively, especially if this is divisible by 4. This is when I wanted to go recursively. Otherwise, I think I wanted to go row by row. You'll do code versus division 2 today? No, I will not. So everything I did here, 90% of what I did, stupid. Again, Saturday evening for Europe, morning for USA, there will be my match against Steven K+. Watch on Eknerwala channel on Twitch. I think you should skip coding it. What time is it? Hour 15? Oh, maybe indeed. It's not an interesting problem. Is there any checklist for Atcoder problems, by the way? Because when I go to tasks, I don't see things in green. Atcoder problem checklist. It's quite empty, isn't it? I only want Atcoder grant contests. I guess yellow is I submitted something. Well, if it was my own list, then I would also mark solved problems, but those where I didn't want to implement. But because this only marks implemented, maybe I should, if I care about this list, yeah, I should implement. How can you say that problem is not interesting? You hurt their feelings. Did I say that? It's not interesting to code now. The solution was just beautiful. The fact that we treat this as a bipartite graph, and then it's so easy. Yeah, that was beautiful. I will implement, and then I have time for one more problem only. But yeah, this is what you have from upsolving hard problems. Am I able to really populate this grid? If they make one Atcoder Grand contest a month and make 1 2-hour stream per week, when I'm able to solve one problem and a half, I think I will barely be able to catch on. Let's implement. Actually, for each D separately, we do something. If this is odd, then we just have standard coloring of chessboard, don't we? Let's think. If it's 4k plus 3, it's impossible to get. If it's 4k plus 1, it's possible, and that will be only odd plus even. So like if we differ by 4 rows and 3 columns, for example, and yes, this will be a different color. This is that. Else do you enjoy getting tracked by Google? I don't care, if that was a question to me. All the companies track you. So the best thing you can do is don't waste time and emotions caring about it. If this is a form I will go with my solution, not with theirs with rotation by 45 degrees. If this, then wait, is this possible? Odd plus odd. This is possible, and it means odd plus odd. 4k means odd plus even. No, even plus even. If it's odd plus odd, I can split into every second row. And finally, we have, this was even plus odd, odd plus odd, even plus even, and I claim that go recursively. What do we do with the grid? This is a positive number, so we cannot always do that. I go recursively, n will become this. Okay. Remember n, the real n. Do this, and now I solve this for some smaller instance, smaller grid, and I need to expand it. Treat this as some kind of temporary array, I guess. Fake. For now every accent y, type of this repetition of xy is equal fake of x divided by something, y divided by something. Like this. Divided by what? By divide. So I will create kind of squares of size 4 by 4 or something like that, or 8 by 8. Each of them will be one type only. Do I need to print this? I need to print the solution. Group of size. There is first bit is this. Second group of this push back a pair xy. If size is enough. And square by 4. How do they number? From 0, just like I do. And done. Exactly the same output. And I don't know if it's the same output. I don't care about getting wrong answer, because it's not the competition with some penalty. So here we go. Even though I could try a lot of random tests and I would see if my asserts fail. Still, I might get wrong answer without that, but yeah, not likely. So we solved, among all those hundreds of problems, we solved this. Now E or F. I will open both and see which one seems more interesting. Also, my submissions. I will see if I was ever close to getting accepted. A lot of time limit exceeded. Without looking at the statement, I'm guessing that I wrote some quadratic solution with hacks. There is a tree and we walk. We're given a small tree and some paths. We need to direct each path, and then for every edge we get point for the first time when we traverse this, and for the first time when we traverse it in the other direction. That should be a nice interpretation. And that's it. Direct the paths to maximize the score. For every edge, we know if it will be at least once traversed. So it's only about maximizing the number of edges where we traverse in both directions. And then I'm fine solving E. Standings. How can you get logic of a problem quickly? Yes, it's by practice. I don't like this dot after 1. The scores aren't big enough that they need to put commas. Yeah, I'm fine solving E. So this is what we will do till the end of the contest. The end of the stream, not a contest. We have a tree. Now, there is some path. Can't I even more increase the font? Don't see how. I maximize the number of edges where we traverse in both directions. Well, the only thing I can decide about is for every color, which direction we go. What if this problem is much easier? what if it's just the tree is a chain like this? Then I can take the leftmost path, I can say direct it in any direction. And then is it true that when I look at the next path, I just direct it in the other direction? If it's like that, then it's obvious. If it's like this, yeah, then I will direct it like that after sorting things by the start, because as I go with this sweep line, let's say, to the right, I only care about two numbers A and B. How far I reach with forward and how far I reach with backwards. So for any new thing, I just increase the smaller value. Yep. Okay, that was easy for a chain. Obviously, it would be nice to do bottom-up tree dynamic programming. We'll grab some water. Again, any thoughts in the chat? Just not the full spoiler towards the solution, but if you're thinking about something, you think, oh, maybe this, why not that? You can tell me. Okay, what can we do? Everything like centroid decomposition and heavy light decomposition is just there to speed up solutions. Heavy light decomposition changes problems into a lot of lines. But what about that? Oh, one more sub-problem. What if this is a star? This is a star. Is it some kind of matching? If something is a single, if there's this red edge and it is a path of length 1, then for sure I can handle this edge. This edge will be in both directions, so I can then forget about it. Then I would recursively forget about this yellow one, because again I will direct it. Well, here I cannot do anything about that. what will be left is a collection of such things. And I think this will be some graph with cycles. Something might be repeated, but then it's only easier to direct things, I'm guessing. Just if there is a cycle like that, blue, orange, red, and yellow, then I can barely direct everything. If there is any edge where we see only one color there, then we kind of remove it. If there is any path of length 1, then we also remove it. Okay, so this subtask was easy as well, just like a chain. And I don't think understanding that will help me here, but it could. How can I watch this stream later? It will be on YouTube. Can we look at this subtree? And after doing things in this subtree, move up. Is it smart for a subtree to finish everything going in the same direction? Let's say here we have yellow, blue, and red. Can it be optimal that all of them point downwards here? I don't think so. I think by flipping yellow, we can only improve the situation? Not sure. Because maybe below there were paths like that, connecting yellow to blue. But then it makes even more sense that blue and yellow will be of two different types. Still, here I care about relative direction of those three colors, red, blue, and yellow. I can solve this problem in exponential time, or like either with total brute force or just with here 2 to k, where k is the number of paths going through the same edge. This bit mask dp. I have no ideas, no reasonable ideas. Something greedy, maybe. I can decide about any path first. Let's say about blue, and I say blue goes in this direction. Can I now decide about any other path? Like find path having most common edges with blue and direct it in the other way. Or what about this? Start with any directions, and if flipping one path improves the answer, do it. It might be bad, because maybe there is some path and it has some stuff on both sides. Here something happens, on the other side also something happens. And flipping blue path is good, but only if we also flip everything here. So maybe more like flip everything in a subtree. Yes, this will be uploaded to YouTube. As I said, the stream will be available on YouTube. Maybe flows. Made network where each path has two edges. Let's think. Oh, isn't it like some kind of two-sat? But maximizing two-sat is... Okay, let's think. Maybe indeed we need to model it as something like two-sat or flow. This might be a good idea. So either flow or two-sat. When we look at this, we basically get a point if it isn't true that red, blue and yellow are the same color. So if I here write down red, blue and yellow, then I lose a point if all of them are in the same group. What do I do with this? If I wanted to satisfy every single edge, let's actually try to find some drawing where it's impossible to satisfy every edge. Because here, if I don't know, yellow and red are in two different directions, then I already satisfied all edges that can be satisfied. Satisfied means they're both directions. First, can this be done? Actually, this is like a star. If I say yellow goes down, red goes up, then blue goes to the left. I think they messed up LaTeX here. Why won't I analyze samples? Of course, the problem would be that the score for a problem would be much lower if something so simple was correct. But seeing any sample, any test where it's not possible to direct all paths correctly might be useful for me. What do I print? 3 and 4. 2, 3, 3, 4, and this. Well, we get the score of 6. So everything is satisfied. Now, second drawing. This was sample test 1. Sample test 2. One, two, 3, 3, 4, 5. And there are paths 2, 4. Then 3, 5. And finally 1, 5. The maximum score I can see here is 2 plus 2 plus 1 plus 1. It's 6. And it's again 6. Maybe the last sample test. One, two, 2, 3. 1, 4, 4, 5, 4, 6. And there are paths. 2, 4, 3, 6. Five, 6. And 4, 5. Let me guess again. Everything is satisfied. 2, 2, 2, 2, and 1. Oh. And a 9. What's going on? If you see any tests where we cannot satisfy everything, please tell me. Like, tell me the test. And I need to finish soon. If there is no such test, you can use 2sat. No, if there is no such test, then I can just count for every edge if it occurs in at least 2 paths. If it is always possible. If edge is hit by 2 paths, I say we can direct in 2 directions. Oh, it's construction. We need to construct this as well. Okay, then yes, it's 2sat. Because just we look at this thing and we say, oh, sometimes, so maybe it's easy, it's trivial to compute the first number, but it's not trivial to compute the other thing. What happens here if we have red, blue, and yellow, and I need to say, what do I need to say? That at least one of them is good. But then it becomes 3sat, right? I say red is this, or blue is this, or yellow is this. We cannot do 3sat in polynomial time or k-sat. If that's the case, then we need to use the fact that it's a tree, but now the goal becomes different. The goal becomes how will we do it? We cannot not use the fact that this is a tree, because then 3sat would be solvable using this. Can you try proving it though? Proving it will most likely be equivalent to solving this. I mean, most likely I will need some insight, and this insight both proves why it's always possible and gives me a solution. I cannot go just bottom up, starting from this, because then if I greedily choose directions of blue, yellow, red, maybe some two of them will be in the same direction. Red and yellow, they meet here. So for sure I want them in two different directions. And let's say, without loss of generality, that red goes here to the bottom, yellow goes up. Now if yellow and blue, for example, they meet here, they don't, but if they did, it would mean that blue must go down. And then it means that any extra path here, wait, blue goes so up here, any extra path here, it goes down. If it has at least one edge common with blue and there is nothing else there. Maybe we always find some path where we can direct it without contradicting with anything. This drawing would be nicer if I could increase the font. I need to find another program if I cannot do that here. I need to open the config file. Oh, I can switch here. That will be better. It's a pity they don't have it here among the 3 buttons. Okay, what do we do? So let's consider this. I will direct some path, and then I'm trying to find places when there is only one not directed thing left. Is this correct? Let's say a moment ago I directed this red thing to this side, and there is some moment where this edge, there is only yellow thing, and also it has some other parts, and now I need to direct it to the left for sure. It has some non-empty common part with red, and then this part is done. I don't see an issue with this. It might happen that there was something blue here, like this. or like that. And then didn't I mess up this? Because blue must be here in this direction to the left. Here it must be up. So did I get lucky here or what? In the end, William won? Like IOI? Did I say he will not win or what? I thought that he has big chances to win. And for sure, like more than 90% for gold. Only AK. AK is short for full score. The only AK. Yeah. What is A? Accepted K. I know that AK is perfect score, but I don't know why. You said there were better people? Yes, a few of them. I think he's... Oh, all kill. I think he's around 5th best. If you make people participate in like 100 contests and take the sum of them, I think he would get around 5th place. But you know, being 5th best in the world is quite something. Like for example, 300 IQ is better, I think. Maybe not. Okay, what will happen later? Blue can go here. Then we have blue going out of this, yellow going in. I don't fully understand. For any question, person X or person Y, you can compare rating in code forces, for example. Then you will see who is more likely to win in code forces. I'm going to greedily here to find any path about which I know how it should be directed. Is that the solution? For sure. I think it shouldn't be difficult in quadratic time, but it seems too easy. Let's see, prefix of the editorial. Let's get the upper bound of happiness. That's obvious. We'll prove that we can always achieve this upper bound in a constructive way. Take an arbitrary leaf and call it V. Okay, so find any leaf with only one edge. What if there is no such leaf? Take 2 walks. They show something. Should I try my solution, where I try to find any path that should be directed? They have something else involving leaves. I don't have leaves. Okay, what about this? Sometimes I don't know what to do. Let's say I directed red, but still there is no edge where there is only one thing. Now there is some other guy, blue, maybe with some intersection with red. Does it hurt that I direct it in the same order? The same thing, I mean the same direction? It seems dangerous, because maybe later there will be this orange thing. But this wasn't the only edge here. Otherwise, this would already be triggered. So there is at least one more thing here. Does it help? If this green continues to the left, then most likely it will be directed to the left anyway, and this edge is satisfied. If it's like this, then if it goes, either it will satisfy this or that, so it seems fine. I guess TwoSat should work if you compress paths, but it's not TwoSat. Why is TwoSat? Sometimes there might be 3 edges at the same place. For a minute there I thought Errichto was playing Among Us because of colors or what? I will do this. I will try to implement my solution. Maybe it will be too slow first. Remove extra paths. I will implement my solution, maybe even in a cubic way or something. And I can run it for random tests and see if ever some assert fails. And after this problem, I'm finishing the stream. Q will be the number of paths. There are also Q things. I need to remember them in some way because I need to print them. Do I need to print them in proper order? Yes. How do I do that? It would be nice here to find a path between A and B. Maybe at this moment run some kind of DFS to find parents and everything. FS of B, and I will not pass parent, I will know parents. If neighbor is not my parent, parent of B is A, height of B is height of A plus 1. This is height, like distance from the root. And now it's easy to find a path between two vertices. Find a path. While not the same, A becomes this is linear, finding LCA in linear time, but also I need to populate those vectors. Actually, I don't need vectors. I just need to say that from A to parent of A there is edge of one type. Up of A push back. No. Let's remember that this is this ID of direction 0. It's ID of direction 1. Now I will know that there is red path going up from me, or there is red path going up from me, but it's in the other direction in the input. Okay. Let's check if I correctly understand how the paths look like. Query of next, I don't pass parent, no. Infinite loop. Infinite loop indeed. What's something wrong with my DFS? Iterate over edges. If B is not parent, then parent of B is A. Height of B is my height plus 1, and go there. Seems good to me. Should wait for me. Oh, I see. Oh. So, why is there 0 here? I guess I didn't copy this. I don't know, strange. 6 and should be 9. 9 indeed. What do we do now? Repeatedly, we try to find some position where there is exactly one direction used there, and there is exactly one path available remaining. And I'm assuming that if there isn't such position, then I can direct any path in any order. I don't know if that's correct. I'm saying like 50-50. We can try betting. Stream elements. So the question will be, is my approach correct? It's different from the editorial. Doesn't mean that it's wrong. Contests. Let's vote with AC and wrong answer. This is the name. Bet AC, bet wrong answer. No, it won't work. How many minutes you have to vote? 5. Minimum bet, maximum bet. 50. I'm not sure how this will work. But wait, will I need to choose exactly one? Well, I will see later. You have 5 minutes to vote. We'll see. We'll see. I don't know how this works. If somebody in the chat knows, you can describe to the others. I don't know what will happen at the end. While true. Go through all the vertices other than the root. If the size is equal 1 and directions of this is 1, then I need to do the other direction. There is only one path with this edge. There is exactly one direction used, up or down. Okay. So fade at the beginning. This is the only element, maybe this is better. This color XOR1, it will be the other color. This is the one I need, I mean the other direction. Now path ID is up of A of 0 dot first. Path dir is up of A of 1 of 0 dot second. I'm making this cubic first, then I will improve. I see that mostly people vote for accepted. Of course, it's not about the first verdict I will get. It's about whether the approach is correct. I will decide if it's correct. Path dir. Now I need to find all occurrences of this. Dot first is equal this path ID. Then do something at the end. Swap this with the last element. Then up of B dot popback. In constant time we can remove from a vector. The order will be a bit messed up, but this doesn't matter. Path dir is different than must be. And then swap Okay, that. And here we insert something to tiers of B. But what exactly? Up of B of I second, XOR, tier XOR must be. I think it will be this. Brackets are unnecessary. If this happened, then done is true. Otherwise, if not done, then I can take any path. So repeat twice. And not done. If not done, break. What do we do in the second run? Can I take just any path? I think so. If for every query, they are numbered from 0. Yes, from 0. Line 88. Oh, this makes sense only if... Okay, I see. If this. Submit, right? I have exactly the same output on the first test, but it means exactly nothing. Not a good sign. Very bad sign. Why didn't I get any time limit exceeded? Wait. Oh, sample. The third sample is wrong. So let me analyze that. I'm very lucky that one of samples is wrong. I have a drawing for that already. This is the last sample. I first direct from 2 to 4. So red will be like this. Then from 3 to 6. No, it shouldn't be from 3 to 6. It should be in the other direction. What about printing? This. For 1 empty, for 2. First with 0, this with 0. For 4, it should be the other way. Yeah, seems fine. I don't know. This is kind of a blind guess, but does it work now? No, still the same thing at the beginning. This doesn't mean that the approach is wrong. I'm quite this must be implementation bug, because after fixing blue with after fixing red with from left to right, blue should be from right to left, like this. So there is something wrong with implementation. Just I need to understand what that is. Let me print which repetition this is. Should be break. I need a break. Oh, that's better. Submit again. I still think this is cubic. If there are a lot of long paths, like all edges are hit by n. Well, I don't like this problem. I think that tests are weak, right? Because every time I go through everything, I have cubic complexity. Whenever I remove something, whenever I fix something, I go through everything. Yes, I'm quite sure I have cubic complexity. And additionally, this solution is quite stupid. Now, let's resolve the bet. So what? You doubled the points? Sorry to all the people who thought it's wrong. To be honest, I would say it's around 50-50 back then. If you bet X, you get X. Maybe what happens is there is this pool of points. Then it would make sense, you know? If, let's say, if 80 people voted this, then what should happen is there should be around 80 points times whatever on average you bet from people betting accepted, 20 points from people betting wrong answer, and then there is 100 points in the poll in total, and it will be split into people voting the correct options, right? I got 28 points, but how much did you vote? Please somebody tell me how much you bet and how much you got. I bet 50 and got 28. Bet 40, got 26. What I think this makes sense, that if there is just one person voting no, and let's say 10 people voting yes, then what will happen, and everybody bets 100 points. 100 points bet. What will happen is, if yes happens, each of those 10 people will get 10 points. If no happens, this person gets 100 points from those, right? Then the total points doesn't change. So you got less points. You got less points because you voted a more likely option. And then, yeah, it's like self-balancing market, where you get rewarded more for unlikely option. I bet 10 points and lost 5 points? What? Is that possible? No, you gained 5 points for watching. Like every 10 minutes watched, you get 5 points for that. So maybe this is why some numbers don't add up. I think this makes sense. No, we are not doing more problems. I'm over 2 hours. This is what I wanted to do. But hey, this was AGC 025. I solved D, I solved E. And I would say actually E I solved without editorial. I only looked up to confirm that the theorem was true. They have some solution with a leaf. I have another one. And let's try to maybe get all of this done. I like Atcoder problems more than code forces. So most likely the plan is this for the future, that I will stream at 5 p.m. European time, my time. So morning USA, evening India. And I'm thinking about something like this. Monday, Wednesday and Friday. And one of those will be hard competitive programming, so Atcoder Grand Contests. One of them will be easy competitive programming, then it can be whatever, and I will explain my thoughts a lot. Like today I talked maybe more than I would want to. I don't know. And coding interviews. That's the plan. So the stream should be around 2 hours. And I will try to do something like that starting from the next week. Hi from a morning in USA. Hello. Just like second thread. Good morning, everyone. Will you do live after today's code forces? No, wasn't planning to do it. Damn it. This, well, problem E was bad, was boring. I didn't like it. Just about guessing something. D was beautiful. And in my opinion, D is more difficult than E. Okay, that's it. Thank you everybody for watching. If you're watching on YouTube, check some links in the description, like for example to Saturday Twitch stream with Steven K+. All future streams in the evening from now? Maybe, I don't know. So this is plan, this is not sure. I'm not 100% sure about it. And also, I'm going to create Google Calendar or something like that, where you can import it. A Google Calendar. And the plan is this. Or maybe I will have only 2 streams per week, but then I don't know which one of those 3 I would throw away. And sometimes a boring stream in the morning, like this. And then I would do my own things, like boring, just a boring programming stream, like in the past. And sometimes something during a weekend. So that's the plan. Those are my thoughts. Professional esports streamer who made CP mainstream professional sport. It will not happen. I do not think so. Yeah, that's the plan. See you next time on Saturday. There will be that 1v1 match with Steven. Information in Code Forces. And I will stream again on Monday, most likely. Monday, 5 p.m. Central European time. but there is schedule on Twitch below this thing, below the video, and also there will be Google Calendar pretty soon. Join the Discord, and thank you for watching. Bye bye.